Welcome back to another session. I'm going to go through BODMAS and BIDMAS today. This does cause confusion as to what order operations should be carried out in, but you'll see as and when we go through this as to what's going on. So this is all about the relationship between operations. A while ago, the following problem was posted on social media. 7 plus 7 divided by 7 plus 7 times 7 minus 7. People were invited to comment as to what they thought the correct answer was. Remember, there are a lot of non-mathematicians out there on the internet, and a huge number of people answered this problem with an answer of 56. They arrived at this answer by reading the sum from left to right in exactly the same way as you would read a sentence in a book. So let's just double check that. 7 plus 7 is 14. If I then divide by 7, I'm going to get 2. If I add 7, I'm going to get 9. If I times by 7, I'm going to get 63. And then subtracting 7 gives me 56. So I hope you can follow the logic there of reading it left to right. This sadly is not the right answer. A convention was established a long time ago as to the correct order operations should be performed in. That convention is called BODMAS or BIDMAS or PEDMAS, depending on where the world you are. And BODMAS stands for brackets, order, division, multiplication, addition and subtraction. With brackets being the most important, followed by order, followed by division, followed by multiplication, followed by addition, leaving subtraction at the bottom as the least important operation. You might be wondering why this is the case. Consider this example as to why BODMAS should be used. A carrier bag costs 10 cents. I buy 3 apples that cost 20 cents. And then I work out the total cost. So 10 plus 3 times 20. Reading from left to right, I've got 10 plus 3 is 13. And then 13 times 20 is 260 cents, or a total cost of $2.60. Clearly this is the wrong answer as the sum has been taken out of context. If we look at BODMAS, we can see that the multiplication should be done before the addition. So 3 times 20 would give 60, and then 60 plus 10 would give you 70 cents. So that is the reason that there's confusion with this topic. If we go back to the original question, let's see, using BODMAS, how we get the correct answer. So 7 divided by 7 is what we're going to look at first, because division is higher up in the scale of things to do than anything else. So if I do 7 divided by 7, which is here in this box, 7 divided by 7 will give me 1, which is now here. I'm then going to do the multiplication, because the multiplication is the next highest thing up. And 7 times 7, that gives me 49. And then we need to do some addition. So 1 plus 49 is 50, plus 7 gives me 57, and take away 7 gives me the right answer of 50. So the difference here is I've performed the sum in convention with BODMAS, which is the correct way of doing it, rather than reading from left to right. Sadly, on social media, there will be many people who disagree with the answer of 50. Convention does not apply to people who do not care about convention. Thus, you may get people making fun of you for getting an answer that is not the same as theirs. Perhaps if they could see the example with the apples and the carrier bag, they'd understand that reading a sum from left to right is foolhardy. With no meaning attached to the sevens in the sevens question, it's perhaps understandable. They're just looking at them as numbers rather than abstract elements to be operated upon in a preordained order. The point is, in all your future work, you should be using BODMAS or BIDMAS. actually, just going back to the carrier bag, it makes sense, doesn't it, that if you have 3 apples that are 20 cents in each, that's going to be 60. And then 60 plus 10 will make 70 cents. It makes no sense that it would cost $2.60. Right, so I haven't looked at order, which is the O in the BODMAS. It appears in different forms around the world depending on which country you're in. So BODMAS, or O, is order. In BIDMAS, the I stands for index, and in PEDMAS, the E stands for exponents. We're looking at powers, basically. Order means powers. If you have a number raised to a power, you will do that before division. So here's an example. 3 to the power 3 will make 27. And if I divide 27 by 9, that will give me the answer 3. You should know that powers are what happens when you multiply the number that's given that many times. So 3 cubed would be 3 times 3 times 3. Double checking that, 3 times 3 is 9, 9 times 3 is 27. Another example here, 2 to the power 4. That means 2 times 2 times 2 times 2. 2 2s are 4. 2 2s are 4. 4 times 4, 16. You need to know how to do powers. And it literally is whatever the number is in the power, you multiply the base number that many times together. Brackets essentially mean you do what's inside the bracket before you do anything else. So if we've got 3 plus 1 plus 5 raised to the power 2 minus 2 times 6, we're going to do everything inside first. 3 add 1 is 4, plus 5 gives me 9. That's that there. And then 2 times 6, that's going to be 12. The next thing that's higher, but below the brackets, is the index, or the order. 9 squared means 9 times 9. And we should know from our tables 9 nines are 81. And if I take away 12, that will give me the answer of 69. Inverse operations. So an inverse operation is the opposite process of another operation. So an example would be pushing a door versus pulling a door. The effect of pushing a door open would be negated if you were to pull the door at the same time. Think of it like 2 people at a door. One person is pulling the handle, the other person is pushing the door. If they're both pulling and pushing at the same force, then there's going to be a 0 effect of pushing and pulling. So they cancel each other out. In maths, you need to know that doing an operation followed by the inverse operation will produce a 0 effect. So 23 plus 7 minus 7 will give you 23, because the plus and the minus cancels. Or if you've got times and divide, timesing something by 3 and then dividing something by 3, you're just going to get that same number. Okay, that's really important to know. The inverse effect cancels the effect of the operation out. So it can also be broken down. Here's an example. 64 divided by 8 times by 2 times by 4 will also give you 64, because multiplying by 2 and then by 4 has the same effect as multiplying by 8, which cancels out the divide by 8. So think of it like this. 2 4s are 8. So I've effectively got times 8, and divide by 8 times by 8, I'm left with what I started with. Simple. Keep an eye out for such factors when you're given questions that involve cancelling down. Simplifying expressions. So, these are another few important rules to know about order of operations. The first one is order in addition and multiplication doesn't matter. So 6 plus 5 is the same as 5 plus 6. And 6 times 5 is the same as 5 times 6. So it doesn't matter which way round you multiply these numbers, you're still going to get the same answer, which is 30 here or 11 here. Okay, so here's a complicated question with lots of pluses and minuses. If you add all the positive components together, 7 plus 2 plus 3 plus 4, that gives you 16. Take away 2 gives you 14, which is that number there. And then on the bottom, you do what's in the brackets first. 3 plus 2 gives you 5. 2 5s are 10, which we can put there. So then, thinking about 14 and 10 in terms of times tables, 14 is 2 times 7, 10 is 2 times 5. I can cancel the 2's, which will give me 7 over 5 as a fraction, and that translates to 1.4 as a decimal. We do that by doing a short division, 5 into 7. Yeah, that's right, 5 into 7 will go once, decimal points in. There's a remainder of 2, 5 into 20, 4. Powers. So when a number is multiplied by itself, you're applying a power. I went through this a little bit in the last slide. 3 times 3 times 3 is 27, or 3 cubed. 2 times 2 times 2 times 2 is 16, or 2 to the power 4. They could also feature in an equation involving BODMAS. So you've got 4 squared, 7 minus 4. So you would do what's inside the brackets first, because that's your b. 7 take 4 is 3. Then we do the I part, which is the index. 4 squared means 4 times 4 makes 16. And finally, we've got the multiplication. 16 times 3 gives 48. Okay, there was no division here, so we ignore the division. And likewise, there's no addition or subtraction, so we don't need to worry about them. Roots. A square root is a number found using the opposite process of squaring. So the way you deal with them is as part of the order or index. Okay, they are secondary to brackets. We know that 5 times 5 will make 25, so the square root of 25 must be 5, because if I take it backwards, I will get 5. Most roots will produce irrational numbers. These are numbers that will never end. So example of that would be the square root of 3, 1.73205, and so on and so on. But you can have nice numbers that you can square root. The square root of 9 will give 3, because 3 times 3 is 9. Cube root is the symbol for cube root. You've got a root with a little 3 above it, and we're looking at the cube root of 8 here. That will be 2, because 2 times 2 times 2 will make 8. And you can generate whatever root you want. So if I was to do the 4th root of 16, my answer would be 2, because 2 to the power 4 is 16. It's just the opposite process, or inverse process again. Reciprocals are defined as 1 over a number. So if you ever see a negative power, you're going to have 1 over that number. So for example, 3 to the negative 1, that's going to be a third. 2 to the negative 1, that's going to be a half. 7 to the negative 1, that's going to be a seventh. It just creates a fraction with 1 on the top. I think that's the best way of describing that. How are we doing on slides? Yeah, I think there's just a couple more. That is also part of the index or order section. Right, so here is a little bit of entertainment for you. Go to YouTube when you're done with this video and type in 7 times 13 is 28 by Abbott and Costello. I'd like to cut this video, get you to watch that and come back to watch this, because it does make a mockery of the whole BODMAS convention. If you want to do that, pause the video, open up a new tab and have a look at the video. So, in the video, the comedians say that 7 times 3 is 21, and then 7 times 1 is 8. No, it's not. Bad boy. 7 times 1 is not 8, it is 7. And then if we add the 21 and 7 together, that will give me 28. Likewise, if we add up 3, 6, 9, 12, 15, 18, 21, 22, 23, 24, 25, 26, 27, 28. So we got a rather unusual scenario here where 7 times 13 is 28, and also we should know that 7 times 4 is 28. Clearly something is wrong. If we know from our times tables that 7 times 12 is 84, if we add on 7, that will give me 91, which is the true answer for 7 times 13 is 28. So I'm going to move that over very slightly. Why then are they getting that answer? Well, it ignores convention with what you're supposed to do in math. If I put 13 down, this is more going back to what we did last time on place value. We add all these 13s up. You've got units here. Adding them all up will give us 21. Now if we deal with the tens, 1, 2, 3, 4, 5, 6, 7, 8, 9, we get the correct answer. So it just goes to show that people have very different ways of doing things, and you're going to get some very strange results in math if you don't learn the proper convention for doing things the right way. This sketch is one of the best sketches I think I've ever seen, and I think you'd appreciate the funny side of it as well if you go and watch that video. Anyway, that brings us to the end of BODMAS and BIDMAS today. I'm going to put a link to some questions in the box below. Have a go, see how you get on, and see if you can generate the answers. Leave you with it. See you next time.